So this video is going to be about completing the square, and this is going to work to either do one of two things. You can either use this to solve an equation, a quadratic equation, when you only have one variable, but in this case we're going to look more at using this to rewrite a function in standard form into vertex form and use that to help us to graph it. So we're going to start off with the simpler case here where there's no coefficient or just a coefficient of 1 in front of the x squared. And I'm going to go through and just show you my preferred method. There are other ones out there. This is just the way I like to do it. So my preferred method here starts off by getting rid of this 13. And the way we do that is we just simply move it to the other side of the equation by subtracting 13. This will work even if you just have a 0 over here. It'd just be negative 13 now. And so we get y minus 13 equals x squared minus 6x. Now this is the part where we want to complete the square. We need to figure out what we can add here to make this part in the equation on the right a perfect square. And to do that, what the rule is we take our middle term, our b value, negative 6, we divide it by 2, and we square it. So 6 divided by 2 is 3, 3 squared is 9, so we're going to add 9 to this side of the equation. Now, because this is an equation, we need to add 9 to the other side as well. And so we end up with y minus 4 equals x squared minus 6x plus 9. Now, the whole point of doing this is now this is a perfect square. It's going to factor out as two factors that are exactly the same. In this case, x and x, we got to get to 9 and add to negative 6. So minus 3 minus 3. And so what we have at this point is x minus 3 squared on one side is equal to y minus 4 on the other. And just by solving for y at this point, we have the equation y equals x minus 3 squared plus 4. And the big thing here is now we know our vertex is at the point 3, 4, because our graph has been translated 3 units to the right and 4 units up. And this is kind of the whole point of why we're doing this. Now, this gets a little more complicated when there's a number in front, a leading coefficient of something other than 1. And it's not that hard to figure out how to deal with this, but just knowing how to deal with it and we'll be able to handle it. So in this case, starting off with a y out there, and we're going to do the exact same thing first. I want to get rid of this 5, so I'm going to subtract 5 from both sides. So we have y minus 5 equals 2x squared minus 4x. Now at this point, completing this square is not as easy. What we're going to do is take everything and divide it by 2. We have to do that to both sides. And on the left-hand side, there's a really good reason to just leave it alone. I'm going to do that. Y minus 5 over 2. On this side, I am going to want to distribute that division. And so I'll have x squared minus 2x.
Lunch students are now dismissed for lunch.
I guess you can figure out when I'm doing this. And so now we need to add on our term to complete the square. If this had created a fraction, that wouldn't be any problem. We'd just do the exact same rule with a fraction. And so 2 divided by 2 is 1. 1 squared is 1. And so we're adding on 1. And because we're treating this like an equation, I also have to add 1 on this side. That's not part of this fraction. It's just a plus 1 stuck on the end. We're not going to combine those terms at this point. I'll show you why at the end. Now, again, this is the kind of the step where we've completed the square, and now this is the whole point in doing this process. This part here on the right hand should factor with two identical factors of, in this case, x minus 1 times x minus 1. And so we'll rewrite this as x minus 1 squared on this side. And I still have this whole y minus 5 over 2 plus 1 thing going on over here. Well, now I just need to solve it back. I'm going to start off by subtracting 1 from both sides. So I get y minus 5 divided by 2 equals x minus 1 squared minus 1. At this point, I'm going to multiply both sides by 2. Now I need to multiply everything by 2. Make sure you distribute your multiplication there. In this case, it cancels out on this side, so I get y minus 5 equals 2 times x minus 1 squared minus 2. Distribute that 2 to both terms. And then I can just add 5 like I would before, because I only combined like terms there. I'm going to get 2 times x minus 1 squared plus 3. And so now I know my vertex is the point 1, 3, and I also know that that 2 is going to tell me that my graph has been stretched vertically by a factor of 2, and I can go ahead and graph this function from that information.